The earlier one,
Yes, sir. Yes, sir. I'm just going to.
earlier one is over.
Yes, sir.
Just 1 minute. I have to receive a call. Just
Okay,
1 minute.
sir. Okay, sir. You just receive, then we will start. Okay,
Hello. Hello. Yeah. Good morning. Yeah.
So a very good morning to one and all present in this virtual platform. At the very outset, on behalf of School of Civil Engineering, I, Dr. Madhulisa Patnaik, coordinator of this FDP program, conveys a warm welcome to our today's guest, Professor Gautam Banerjee, in this online 5-day faculty development program on recent advances in forensic analysis in civil engineering, which is sponsored by AICT Training and Learning ATAL Academy during 27 September to 1st October 2021. So now we are going to start our session 11 on forensic in civil engineering, its field and application in sewage and wastewater treatment system by Professor Gautam Banerjee. Now I would like to take the privilege to introduce our guest. Professor Gautam Banerjee belongs to environmental engineering discipline with bachelor in civil engineering and master's and doctorate in environmental engineering. He has sought reputed institutes like NIT Durgapur as lecturer, NIT Kharagpur as assistant professor, AIIH and PH Kolkata, GOI as assistant professor, AIT Bangkok as visiting professor, and presently serving IIT BHU as professor in civil department since 2004. He also sought Public Health Engineering Department, Government of West Bengal as assistant engineer. Professor Banerjee has conducted some R&D project sponsored by World Bank, WHO, UNICEF, IDRC, Canada, as well as various Ministry of Government of India like MNEC, MUD, MRD, MLA, and Government of WB, UP, and Tripura. As expert consultant, he has also been associated with several consultancy work related to water supply and treatment, wastewater and industrial efficient treatment, and solid waste management, environmental impact assessment, environmental auditing, and few other related areas. He has gained many PG, he has guided many PG and PhD scholars, and he has published several research and technical papers and attended many national and international conferences, symposia in India and abroad. He has organized national conferences and conducted good number of training refresher courses for practicing engineers in different states of India under the aegis of WHO and CPHWO, MUD and MRD, Government of India. He has served IIT Mumbai, IIT Delhi, IIT Guwahati, and IEST, NITs, and KIT, etc. as an examiner. He is a regular reviewer of international reputed journal as well as a project proposal which is submitted to GOI and GOUP and GOWB, etc. As guest faculty, Professor Banerjee has delivered several technical as well as popular lectures in several institutes and organizations. He has also served as an advisor of School of Water Resource Engineering of Javadpur University and Government of Tripura, and expert member of National Board of Accreditation MBA of AICT and GOI, WB Pollution Control Board, and HRD Division of American Center, Kolkata, etc. So beside this, he is a member of Selection Committee and Board of Examiner of several institute and PSCS and UPS and MHRD. He is a life member of some professional bodies as well. So not taking much time, I would like to invite Professor Gautam Banerjee sir to please start the session. So over to you, sir.
Yeah. Thank you, Dr. Madhulisa, for giving my introduction. Although that introduction, really speaking, does not directly relate to this particular topic, which I have selected and keeping in view of your broad sort of conference theme also. So forensics, this particular area, as all of you know, that first at the outset, I should welcome all the participants, including the coordinator ma'am, to this particular technical session, where I will talk the forensics in civil engineering, which is in line with the webinar theme, and its applications in sewerage and wastewater system. So that is actually the topic of my presentation today. Now, the forensic in engineering is a very, the technical, it was a technical jargon type, but now it has come to the reality. Can you hear me, Dr. Madhulisha and
Yes,
others?
sir. Yes, sir.
Okay. So I'm putting my video also on, just get introduced with the other members also. I think I'm visible on the screen. Am I visible?
The screen is black like.
Okay, okay. Uh, now it is okay?
Yes, sir. Now it is.
Okay, okay. So, but I will not continue to put it on the screen when I will go to present. Okay.
Yes.
So I'm putting it off now. The forensic in civil engineering, this relatively is, I should say, younger sort of, area, which has been very much relevant because the importance of civil engineering and particularly the infrastructures development is going all over the world in general and in particular our country. So lots of complaints, lots of, episodes of failures. So this we have seen in recent past, which is related to civil engineering structures or infrastructures also. Because this is very important, as you know. Civil engineering is a wide domain. Uh, the structure, the construction, the foundation, the geotechnical engineering, transportations, then water resources engineering, then environmental engineering, and so on. So many areas are included in this particular discipline of civil engineering. Now, I have divided my or organized my today's this presentations into two uh, PPTs or so. So the first one will deal with the general aspects of forensics in civil engineering, and then I will switch over to the application part, where actually I was directly associated, and we did an extensive field work related to that, particular case studies also. So the first, this one, I will go to present this one. And while let me just clarify, the first one is not really a sort of, my own work also. So that is why it is not, subjected to that copyright also. But the second one I have written also. So that actually is subjected to that because the publishers is involved. So that is why, part of that with if it is to be reproduced somewhere. So in that case, it needs permission also. So
Excuse me,
the
sorry,
first one,
sorry,
let me, yes,
sorry to interrupt. Sir, are you sharing the screen?
yes,
It is not
yeah,
visible.
I'm hearing. I can hear it.
No, ma'am, is sir
You have
sharing?
not shared your screen. I think you are going to share your screen. Right? I think you have not started the PPT.
PPT, I have not yet started.
Okay,
Yes,
sorry,
yes.
no, sorry, my bad. I thought you were saying you have written, so I thought you were sharing.
No, just I mean, before I mean going to the
Yes,
PPT,
yes.
I
Yes,
just
yes.
was trying to sort of I mean communicate that how I am going to organize
Yes,
my
yes.
presentation.
Sorry, sorry.
So I'm yet to sort of I mean present this. So now I'm going to present, and if there is any issue, so definitely you must point out this one. First, am to share the screen. Okay. So can you see this?
Yes, sir.
Okay. But the part of that actually is guarded by this one. Anyway, it doesn't matter much. So the forensics in civil engineering, its field applications in sewerage and wastewater treatment system. Part one is a general one, as I have told. The forensic engineering, I think that as the very theme of this particular webinar being conducted by Dr. Madhulisha ma'am. So this relates to forensics and civil engineering. So this may be overlapping. There may be some persons or some speakers, eminent speakers have already talked some part of that. So in that case, I don't know that which will be really overlapping also, but I will go first. If you just point out that okay, this has been done, so I will skip that. So forensic engineering is the application of engineering principle to the investigations of failures and other performance problems. So uh, there is nothing much to say here. I think all of you, the participants, are well educated and well versed in this field of civil engineering in general, and in particular forensic engineering is nothing new. This particular sort of definition or description, all of you know. So if you have got any sort of uh, particular sort of terminology or sentence or so, if it is so let me know that then we can explain uh, a bit more details also. So this basically, as you know, that in civil engineering, a lot of these episodes or complaints, these actually, reach uh, honorable courts of law.
Yes, sir.
Architectural materials and products, facades, structure interfaces, and interactions, innovations in facade and roof assessment, then adapting legacy facades to modern requirements also. So these are the building enclosures means here within the building or so. So that what should be sort of relevant to the forensics engineering. Infrastructure performance, that is the pipelines, water and wastewater, particularly these areas I will discuss in my second presentation. dams, levees, treatment plants, recreational facilities, special structures, then transportation, including airports, highways, parking facilities, tunnels, transmission towers, wind turbines, and all. The natural disasters and extreme conditions, the failures caused by tornadoes, hurricanes, earthquakes, uh, then tsunamis, etc., blast and impact loading, fires, then risk management, emergency response, lifeline engineering. So these are the areas or the components coming under that natural disasters and extreme conditions. Technologies for forensic investigations, that is the emerging technologies, the machine learning, as all of you know about that, part of artificial intelligence or AI, building information modeling. Nowadays, that also has become very popular, particularly in the architecture uh, area. Structural health monitoring. This also has become extremely important because there are several government, infrastructural projects uh, actually are being carried out, being constructed also, and where as third parties, the reputational institutes or organizations are got involved in this checking of the structural health also, because you know that in civil engineering a lot of things go which many a time are not really healthy or so. So healthy in terms that of the it's the honesty, or the purity in making or erecting the structures also. Remote sensing, non-destructive testing, and sampling and analysis also. And in the this as footnote, machine learning, all of you know, so that actually uh, is defined here. Now, forensic engineering education should include historical failures for which the uh, forensic uh, engineering, particularly civil engineering, this that has been very much deeply involved. That historical failures for rehabilitation or repairs also. Use of case studies in forensic engineering education, teaching the investigation process, which is very, very important. In fact, forensic engineering course content. So this is the education part where if suppose in the civil engineering curriculum, forensic engineering as a subject is included. So these actually must have to consider these components apart from others. Construction performance and safety. So this is the, I'm not detailing those things. You will get in my PPTs. Professional practice in forensic engineering. That is very important. In fact, in our country, it is not emphasized or practiced rather that much. But in Western world, actually developed world, this is very important. Engineering ethics and case studies of ethics, code of ethics, conduct violations, and all these, as you see on the screen. I think the screen is clear to all of you, right? Is it readable?
Yes, sir.
Okay, fine. So just one small example I to give here. When I had been to, West Indies, in Trinidad, and I was roaming around this US and some institutes in, or organizations, professional agencies in UK. I just happened to ask that what is the chance of failure of a bridge or a building in UK, say. So the expert, these engineers of a particular organization, so they told that They actually was surprised. Why you were asking? I told that there is always a sort of, likelihood of failures or so. Then he, or rather they told, the team told, that possibility is very rare, in our system it is very rare, because uh, our engineering ethics, or that code of conduct or so, that is strictly adhered to, because without which you will not get the professional degree, uh, by which, or based on which, you can practice civil engineering. So uh, civil engineering, if you see from a sort of academic point of view, then you can do many things. You can sort of, study or teach many things. But when you practice, then you must have to adhere to the ethics, conduct. So that is, stringent, as stringently as possible. Otherwise, your license will be taken away, and you will be jailed or so. And each and every professional, particularly in civil engineering discipline, they had to take an oath, and they have to give undertaking. That is an integral part of the professional, you know, membership, or professional, so workmanship also. So that is very important. But in our country, it is yet to come, but it has not been fully operational, I should say. So this is very important. We have got a lot of codes, as you know, being civil engineers, all of you know, I think, that there are a lot of codes, IS codes, ISO, also manuals also, which we follow in design, in execution also. But many a time we do not attach much importance to ethics or the conduct also. So that is actually I was going to tell. Now, repairs and remediation, the structural repairs, innovative approaches to repairs, strengthening methods, advanced construction materials and methods, repair induced problems. So I have given, you see that two different links, which will take you to the details of these components uh, related to repairs and remediation. Now, concrete, as you know, that is widely used. Precast element, and used in cast, or rather in situ, the walls, floors, foundation, etc., etc., etc. And there are some sort of Euro codes and the equivalent codes here. That is actually that is this is guarding the screen actually. Uh, Anyone can remove that in the, because it is guarding that my presentation here on my screen. Anyway, that IS 1199516, and there are other these codes also. I will give some codes, the name of, for the number of codes later. So actually, with regard to the strength, durability, resistance, movement tolerance, etc. So when installed, actually, that installation is done, forensic examination is required. Can I? Oh, right. Now it is okay. Now, there are a number of, uh, techniques available, forensics and failure analysis also, which may be split into two categories also: site investigations followed by laboratory analysis. All of you know that this is nothing new. Site investigations, an initial desk study based on information also. That means that the topography, then the plan, then the site plan, then the key plan, as you all know, then the design, then the drawings, GA drawing, general arrangement drawings also. So after that, uh, Depending on the apparent failures, a program of intrusive and non-intrusive sampling can be carried out. Intrusive coring of samples to establish the depth of cover to reinforcement bar or rebar, construction of slab column beam, presence of honeycomb beam, moisture content and density, and depth of foundation. So these are the intrusive the sampling, while non-intrusive investigation that includes mapping of rivers using Hilti ferroscan. I don't know that how many of you are familiar with that Hilti ferroscan or other ferroscan. Hilti means is a special group attached to that, so it is a sort of the ferroscan basically. So I'll show a short videos on this ferroscan, then the ground penetrating radar or GPR, then estimated the comprehensive strength using Smith hammer or Windsor pin, presence of movement joints, drop hammer testing of skids to establish strength, slip and skid testing of surface, particularly in highway engineering, half cell potential also. So some of these are defined here. That is, for example, that the half cell potential that actually is used to determine the probability of corrosion within the bar in reinforced concrete structures. And movement joints videos I have included in my PPTs, the videos, I will show that. And to assess if your screed is adequately compacted also in case of the highway sort of construction also. Now here, this is a video where you will see this one. Just let me know that whether
I think so. This video is not audible, right?
yes, anything?
Is it audible, sir? Like any voice is there for this video?
Yeah. Are you not able to hear this?
No, I'm not able to hear this.
Okay, okay.
Participants, do you can you hear
Just
this
one
one?
moment.
No, no.
No.
It's not coming.
No, sir. No voice is there.
On this.
Still no, sir.
Oh, oh, just one minute. Can you hear now?
No, sir.
Oh, I don't know why it is audio setting. Can you see? Can you hear?
No, sir.
We can
Hello.
see, we can see, but it is not audible actually. We can't see any voice. We can't hear any.
You can't hear.
Yes, sir.
Oh, but I don't know actually how to. The time will. But you can see, right?
Yes, sir. We can see.
Can anybody help in this regard?
We can see, but you just explain this one. Actually, it is not audible to us. So you can explain the things.
Okay.
A wet sponge is placed between the porous plug of the
Now
half
it's
cell
audible.
and the concrete wall to complete
Audible.
the circuit.
So shall I start
Potential
from the
measurements
beginning?
are taken.
Yes.
This is a demonstration of ASTM C876, the standard
clear?
test method for half
Yes,
cell
it is clear
potentials
now.
of uncoated
Okay,
reinforcing
good.
steel in concrete.
I have checked actually sharing
A
that.
copper sulfate solution is poured into the half cell container. A 1/4-inch diameter copper rod is then immersed into the copper sulfate solution and the cell is sealed. The half cell is then screwed onto a voltmeter, and the protective cap is removed to expose the porous plug at the end of the half cell. The negative lead from the half cell is connected to the voltmeter, and a long positive lead is also connected. Rust is first cleaned off of an exposed reinforcing bar protruding from the concrete area to be tested. The red positive lead from the voltmeter is then clamped onto the bar. Prior to measurements, a grid is laid out with 1-foot spacing spanning across the concrete surface to be tested. A wet sponge is placed between the porous plug of the half cell and the concrete wall to complete the circuit. Potential measurements are taken at each intersection along the grid. The measurements and their corresponding locations are recorded, and this data is used to generate a contour map of potential corrosive sites beneath the concrete surface.
So I think you have been able to, all of you have been able to hear and see this the video.
Yes,
Yes.
sir. Yes, sir.
Okay, good. So now next video I'm starting.
This tutorial provides an overview of the Hilti Profisferoscan map software and explains its main
Please
applications.
point out if you
This software is designed to
not,
arrange
hear
multiple
or-
image scans or quick scans recorded via the Hilti Ferroscan on a virtual wall. The resulting map shows the rebar layout and depth of concrete cover. Different colors can be assigned to indicate and visualize individual depth layers. The area visualization and provided statistics give you a solid foundation to form your decisions. Now we'll go through how to optimize the handling of large amounts of scan data. First, the scan files need to be analyzed in Profis detection before you import them to the Profis Ferroscan map software. This step enables the processing of scan files from a complete project. In the Profis detection software, the Ferroscan batch processing function automates the analysis of large amounts of data. After the batch processing is complete, you can open the Hilti Profis Ferroscan map application. Within the application, you can change the basic settings for language, length unit, metric or imperial, preferred color map, and the archive folder. The color map allows you to assign color codes to different depth ranges for better visualization of areas with inadequate concrete cover. The toolbar includes options for opening an existing Ferroscan map project or creating a new map for quick scans or image scans. Let's create a new map to show how these features work in practice. Create a new map file by clicking the Quick Scan Area button. Enter the project information in the virtual wall properties, including dimensions and the distance between the scan lines. Select a project folder from your archives and import the analyzed scan files for mapping. To arrange the scan files in the correct sequence or order, select Advanced Direction and Scan Direction using the arrow symbols. The start position where the first scan will be inserted is shown. The upper left corner is the default point of origin for the map visualization. Each subsequent start position is advanced to the amount in the Advanced Direction increment field. The scan direction is the starting position of the quick scan recorded via the FAROScan. Depending on the sequence scanned, choose to add selected scans individually or add all scans. Once you've placed the scan files, the multiple quick scans will appear arranged on a virtual wall for depth of cover analysis. In large area visualization, use the zoom function to see more detail. Remember, you can adjust the map's color code according to your needs and preferences. A good first step for evaluating the area is looking at the statistics overview. This may give you ideas for setting the color map and further processing of the viewing settings. These statistics results are dependent on
Hello.
Yes, sir.
So it was audible?
Yes, sir. It was audible.
Okay, okay. But where is my this PowerPoint?
So again, you can share your screen. Actually,
Yeah, I have to now.
yes, sir. It is visible, sir. You can do it full screen.
Yeah, it's okay, right?
Yes, sir.
So I should go back to the.
Welcome to the Fundamentals and Theory of Ground Penetrating Radar by Geophysical Survey Systems. We will introduce you to the basic concepts of GPR, how it works, and how to interpret the data as it is displayed on your screen. GPR stands for Ground Penetrating Radar. It's an electromagnetic
Is it audible
energy
and
signal
visible?
that penetrates through the subsurface.
Sir, it is audible and visible.
GPS systems are typically comprised of three elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated here. For example, the Structure Scan Mini contains all three components in one dedicated.
Now the video is not playing. Lost.
You are not able to hear, no?
No.
Yeah, just now.
No.
Can you hear and
No, we can't hear.
you can't?
No, sir, we can't hear. We can see, but we can't hear.
Systems are typically comprised of three elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated here. For example, the Structure Scan Mini contains all three components in one dedicated system. The antenna has a transmitter and a receiver. When the signals are returned to the antenna, we record a two-way travel time and the amplitude of the signal. The amplitude is simply the strength of the signal coming back. Antennas come in various frequencies, depending upon your application. High frequencies are for shallow depth and small targets, ideal for concrete applications. Low frequencies are for typically deeper depth and larger targets, such as utility, geological, and archaeological applications. Survey areas with high conductivity can limit the depth and effectiveness of ground-penetrating radar. An example of this would be clay soils, or uncured or green concrete. Here is an example of objects or targets underground and how the data will be displayed in real time. As you collect the data, note the hyperbolas, or upside-down U-shape, when targets are crossed at 90 degrees. When you back the antenna up, a cursor will appear on your screen. By bisecting the hyperbola with the cursor, this will mark the horizontal location of that target. Through different mediums, a value is assigned to these mediums to represent different velocities of radar. This value is called dielectric. Dielectric is important so the depth of targets or layers can be accurately estimated. Air has a dielectric of 1, which means radar travels fastest through air. Water has a dielectric of 81, which means radar travels slowest in water. Every medium in the world falls somewhere in between. Lastly, remember that GPR is electromagnetic energy. Other sources of electromagnetic energy, such as cell phone towers and two-way radios, may interfere. These will not cause any damage, but may make it more difficult to see deeply into concrete or soil. In addition, unlike X-ray or other technologies, ground-penetrating radar is not harmful and has no site restrictions associated with use. This brings us to the conclusion of the theory and fundamentals of ground-penetrating radar. For more information on data interpretation and specific applications, please visit www.geophysical.com. Thank you.
So, was it visible or not? I am not sure.
Yes, sir,
Hello?
it was audible and visible.
Okay, fine. So we are now 3 videos you have seen. One is was related to that the half cell potential to determine the corrosion probability or the extent of corrosion also. Second one is that the ground penetration or the ferroscan, that is the Hilti is a company, the Hilti ferroscan. They are specialized in this field. And the third one is that the ground penetration radar. So these 3 you have seen. So let me now go to the next slide. Is it clear? Is it visible on the screen, the slides?
Yes.
In this video, we'll be covering a quick review of the rebound hammer testing method. Since its introduction in 1948, the rebound hammer has become extremely popular, mainly for its simplicity and ease of use. It is an inexpensive and quick method for non-destructive testing evaluation of concrete hardness. The main applications for the rebound hammer are to assess the in-place uniformity of concrete and to estimate the in-place strength of concrete if a correlation is developed. As listed, there are several standardizations that currently exist for the rebound hammer. In order to test, the plunger is pushed against the concrete perpendicular to the surface. As the hammer body is pushed towards the concrete, the force causes the latch to release and make an impact on the concrete. Essentially, The rebound of the spring-driven mass is measured after its impact with concrete surfaces. The output of the rebound hammer is then referred to as the rebound number, and this is correlated with the surface hardness of concrete. A higher R number means higher concrete hardness. The rebound hammer can be placed in many configurations, including upwards, downwards, at any intermediate angle, and horizontal. Inspectors should pay attention to the following considerations prior to conducting a rebound hammer test. The testing surface should be at least 150 millimeters in diameter. The surface should also always be smooth before testing. If there is any free moisture or water on the concrete surface, it must be removed. And finally, it's important not to test on frozen concrete, and concrete should only be tested after it has thawed, since frozen concrete tends to have high rebound numbers. Although the rebound hammer provides a quick, inexpensive means of checking the uniformity of concrete, the results can also be affected by the following parameters: smoothness of the test surface, size, shape, and rigidity of the specimens, age of test specimens, surface and internal moisture conditions of the concrete, type of coarse aggregate, type of cement, carbonation of the concrete surface, and type of mold. Although no theoretical correlation exists, certain relationships are applied to convert rebound values to strength values. The ACI 2281R and the EN 13791 have certain guidelines in order to evaluate compressive strength of concrete. According to the ACI 2281R, in order to establish a relationship between the rebound number and the concrete strength, inspectors should take a minimum of 2 replicate cores from 6 or more locations. According to the EN 13791, 1 core should be taken from 9 different locations. With recent advancement in sensor technology and development of wireless communication, a new generation of rebound hammers are commercially available. Recording and tracking job-specific details including hammer angle and on-site verification of test results was time-consuming and prone to errors. The new generation of hammers help engineers get around these issues. For example, new generation hammers apply real-time checks on the quality of datasets and do not need to be adjusted for the configuration of the hammer. To learn more about F'(C) and the non-destructive testing solutions that we offer, visit our website at f'c.com.
Can you see?
Yes, sir.
And could you see and hear the earlier this video?
Yes, yes.
Okay, good. Sometimes it is happening maybe because of the video problem or my setting problem also. So whenever it is so, please point it out, okay? So that I can understand that on the other end, whether participants are able to see and hear.
Yes.
And this slide talks about the laboratory analysis, that is that according to BS, the British standards, and this 2 standards are given here. The compressive strength, mixed proportions, petrographic analysis, sulfate content, chloride content, depth of carbonation. This is defined also. I have here included the definition and the significance of that depth of carbonation also. So that is basically, that the carbonation depth is the average distance from the surface of concrete or mortar where carbon dioxide has reduced the alkalinity of the hydrated cement. When the carbon dioxide penetrates, so that actually, that reduces the alkalinity of hydrated cement. As you know that hydrated cement, this basically is alkaline. Is maybe 12 to 14 the pH then. And carbonation is the reaction of carbon dioxide in the environment with the calcium hydroxide in the cement paste also. So when there is a void or crack or so, the carbon dioxide will have opportunity to go deeper and will react with the calcium hydroxide and will form the calcium carbonate, and it will lower the pH also. That means the alkalinity will be poorer, and it may go down to 9 or so. At this value, the protective oxide layer surrounding the reinforcement steel breaks down and corrosion becomes possible. So that is why actually the depth of carbonation is required to be measured. Then alkali silica reaction, presence of high alumina cement. The petrographic analysis, and let me talk that regarding the earlier one. These actually in India also, in our country also, there are multiple codes addressing this test. I think many of you may be knowing also. If you are interested, you can just type on Google or any search machine or so. So you will get that the IS code number also. Some of that these actually I can provide later. Petrographic analysis here, as you see that this is a diagnostic tool for examining failures in concrete. So here actually first the visual examination is carried out in order to ascertain the possible causes of the problem and to determine the best position for taking samples. And then you are aware, or you are sure that from a particular zone or position you have to take the samples, and then core samples, and take to the laboratory for petrographical this analysis also. Then that could be done through SEM and polarized light microscopy, and other these methods also are there. Candidate methods are there, and you can be guided by these British and US standards, ASTM and BS, the numbers given. Now, benefits of petrographic this analysis is that determining the present condition of previously placed concrete, so that the decision to reuse or replace can be decided. Establishing the root cause of sulfate scaling, spelling, then aggregate pops out, and abrasion. Popping out, I will give a figure later. Defining cracks by type and uncovering cracks mechanisms, then explaining causes of concrete degradation, primary mechanisms, and these are the reactions or mechanisms. So these are listed here, and the link also I have provided here, that you can get through this link that the detailed procedure to find out the parameters which determine that forensic examination or that petrographic analysis in particular. So as you see here, the hardened concrete, and ASTM is given, but here BIS also is given. That I have provided, I have included here the comparable BIS, that is SP 3 1982. Now, concrete admixture testing. So when admixture is used in concrete, so that actually, as you know, admixtures are commonly used to control the concrete flow, shrinkage, air entrainment, setting times, both regarding and accelerating, retarding and accelerating, and water reduction, corrosion inhibition also. So for that also, actually the procedures are there to test or analyze the admixtures which have been used or to be used in concrete also. So here that you see that the test which should be included, that is that different, this one, I think that I cannot see this, the guarded, this one. Can you see that the top line, all of you? Top line. So they are actually the 9103, I suppose, that actually gives this admixture testing, because I am not able to see the top line here. Okay. Can you hear me, Dr. Madhulisha?
Yes, sir. Yes, sir.
Okay. So can you see the top line? Because from here, I can't see on my screen because this is guarded by some sort of, icons.
Now the top line is like the test could be conducted, right? Test could
According to?
according to the BSEN 934.
Yeah.
Yeah, that line we can see.
Okay, but I can't see, so that is why I was guessing that. I was wondering whether that the code is visible or not.
Yes.
Visible,
So
sir, visible.
visible. So in counterpart IES codes are there for each and every this parameters. I think many of you have been using these IES codes for different purposes or so. 456 2000, all of us know. But apart from that, the mixers, then hydrated cement, this one, the OPC, the ordinary Portland cement, the testing of these, the chloride content, IS 6925. So these are here, maybe in multiple codes, but these are available. Then raw material, this evaluation, this is very important. As you know that the concrete or mortar, this comprises cement, then the sand, water, aggregates or so. So the cement maybe this originated from the limestone shells, chalks or marl. Marl is a special geological, the rock type, combined with shell, clay, slate, etc., etc. So how the cement is manufactured here, just a glimpse of that you can see. And as all the ingredients are involved, are required as raw materials to manufacture cement, so obviously the quality of raw materials have to be sort of ensured also. So I'm not going into the details of that. So you can see this later. Next, concrete repairing agent testing. When the concrete is repaired by grouting or other means or so, by epoxy, this painting or some resins or so. So how you can test? So that also in some codes, I cannot right now say the code number, counterpart IS code, but here BS, this that EN 1504, so that is there, and this is harmonized with the European counterparts. So this is about that a particular this structural engineering laboratory, that Lucidian. So that there is actually the international this company. So they have got the forensics, that the expertise and the facilities for forensics examination in civil engineering in different areas of civil engineering. So that actually this particular slide, so that speaks about that. These are the different these codes. Skipping this one also. This one also. Here, what I was telling, that pops out, aggregate pops out. So that actually is given in these two diagrams. What does it mean? Aggregate popping out in concrete or so. So that looks like this, the popping out. And there is some sort of reasons for concrete to pop out. So that we have already discussed and we have to go for the forensic examination, why the concrete is popping out, or I mean the road has got the potholes or so. So all this could be, tested on the basis of intrusive as well as non-intrusive sampling and testing. So this is all about that. The first this presentation. So this is open for discussion. For 5 minutes we can discuss. We cannot afford much time on this actually. You can sort of, you can take my email from coordinator ma'am, and if you like to interact later also, then you can always, you are most welcome. So any questions?
Any questions from participants? If you have any questions, then please do ask. I think, sir, there is no question from the participant at this
No
point.
problem. No problem. This is a very, I should say that new and upcoming area. So many things may not be familiar with the system. So that actually, and as I do not really belong to structural engineering, I also have got limitations also. My area is environmental engineering and water development also, water resources development. So, so we can take a break, Dr. Madhulisha ma'am.
Yes, sir.
We can take a break of 5 minutes. Would it be all right?
Yes,
in
sir.
between, or we can continue?
So you can continue if you have if you want, sir, then you can take. There is no problem.
Okay. No, I like to continue. No problem.
Okay, sir. Okay, sir. Fine.
So next presentation. Can you see this?
Yes, sir. Part 2. Yes, we can see them.
Okay, fine. So here you can see that copyright issue that is there, because these are actually the case studies where we were involved, and court, honorable high court was involved. So that is why it is strictly sort of prohibited. If anybody wants to produce also, he or she can sort of take permission also before using this, or before quoting this anywhere. So forensics in civil engineering, same sort of title. Part 2, case studies. So this case studies in fact pertains to a sort of sewerage system which was laid, and it was linked to that the sewage treatment plant. As you know that, if I just briefly, go for the procedure very briefly. That is, as you know, that the sewerage system, all civil engineering, this teachers and persons. So they know, all civil engineers, they know that how the sewerage system works. They collect the wastewater from the domestic units and establishments also, that, and this is taken through pumping sometimes, or by gravity, and it goes to the reaches the treatment plant where it is treated. So sewerage system, in fact, is the first one. That is the network of the waste collecting conduits, or the pipes, or some conduits may be different from pipes. So that sewerage system, when it is laid, first thing is that when it is, it is planned, designed, or so, and plan to be constructed also. So the procedure is there, as all of you know, for any construction or any civil engineering works. Here also it follows. But when it is laid, and then many problems, complaints, in fact, crop up. This case study is based on a complaint lodged through PIL, public litigation, information litigation or so. So that appeal to the High Court, and the High Court actually, and that was lodged by a lawyer. So the case was very critical about the sewerage system. So the lawyer's complaint was that it was defective, and the contractor and engineers, they had a nexus, and they didn't sort of perform their sort of assignments or works honestly. So that actually triggered the High Court's verdict to go for forensic type analysis and reporting. So I was one of the members in that committee, among two members. So I was one of the members. So the post laying and under construction already in place. So invert level, of all of you know that the sewer line, the bottom, this one, and the thickness, if you consider the bottom upper this part, so that level actually is defined or taken as invert level also. So this actually, you see that here the verification of invert levels of sewer already in place. So after the sewer line was laid, we were checking here. I myself that is shown. I was seeing through that the leveling, so that the stuff reading and the leveling of that and invert levels, we were trying to find out that invert levels at random. That means randomly, not from all the manholes, but strategically, some manholes where the problems were there. So we checked the invert level of the manhole, and as well as the incoming and outgoing sewer lines, from and to the manhole also. This is the checking of the invert levels in a particular sort of place, and the distances between the manholes also was seen, whether it was it was correct as per the requirement or tender document or so. Then checking quality of sewer pipes. So we literally checked, as you see that I was just touching that the pipe by bending this one. So that is myself, and that actually means that checking that whether the diameter of the by physical examination or so, the pipe is okay or not, the diameter, the thickness, the wall thickness. So we were checking that and recording this one. Then the RCC pipes damaged at one end. So this actually, why did this happen or so? And we took the samples to the laboratory and analyzed that, checked that one for strength, and we did the reporting. Okay, and whether the pipe or sewer pipe was as per the tender document or so, as per the contractor's version. So that we were checking that the reinforcement in a particular pipe at random, we got broken, this pipe, sewer pipes, and we sort of checked the weight. Here you see the reinforcement cage, a pipe which was already damaged, or some pipes at random we took, and we got it broken totally. And then the cage, reinforcement cage, we got that one, and that is visible here. Same thing, another for another pipe, and we were checking the weight. So, as you know, that sewer, the reinforced pipe or RCC pipe. So the given this one, say for example, NP4 or NP, non-pressure pipe 3, 4, like that gradation is there. So which was documented in the tender, and which was supposed to be laid by the contractors, assigned contractors also. So we checked that whether a particular sort of, this sewer diameter or so, whether that maintained that one, or inferior quality of pipes, sewer pipes were used or not, in terms of the reinforcement requirement. So that we physically verified, as you see here. So we took the weight of that in nearby this workshop or so, and we saw that the percentage of that compared to the percentage of that the total this pipe weight, and that the given or stipulated percentage was at all okay or not. So that we checked here. Now here, you see the road settlement around manhole is mainly due to the natural consolidation of soil. So while constructing manhole, in fact, there were some manholes which were wrongly constructed or not constructed in a proper way, and that led to the the breakage of roads or the settlement of the road, as you see here. So in lot of places, particularly during this monsoon period, that the road got settled, manhole broken. You can see this road settlement near the manhole. Then these actually we checked physically, and we took the samples and got tested in the laboratories or concerned nearest laboratories, NIT Allahabad, sometimes our place, sometimes IIT Kanpur, or some reputed organizations also. Checking of construction of sewerage system. You see that when the sewerage is laid, manhole is already constructed or so, and how it looked like. So we inspected the manhole, the manhole under construction, which was under construction, whether it was properly constructed, and then the masonry work, then the pipe, sewerage pipe, the invert levels, and then the quality of the pipes. So all actually were physically, inspected also. And here you see that when it is a deep laying or so, that means sewer pipe, it here on the right side, what you see, that is actually 9 meter deep, the sewer line. So that actually sewer pipe was being laid 9 meters down below the road surface also. So whether the procedure followed was correct or not, that also we physically verified also, and how the laying process was going on. Here, when a particular sewer line has already been completed or so, then we tested that the wastewater or sewage flow, whether the gradient was given correctly or not, and the sewer line, because we cannot break, we could not break that that one by excavating and damaging the road or so. So what we did actually, we poured that simple this water from the tank nearby. This one you can see that the tank nearby. So from there actually we were pouring that the water, and from another manhole we were checking that this is that another manhole, whether the flow was okay or not, and the velocity also we were seeing. That means from a particular manhole, when it was pouring started, the other manhole at a particular distance, 30 meters or so, 100 feet around. So how much time it took, and inside the manhole also, what is that the a float, or sort of very light kind of this one, like thermocol or so, ruggedly thermocol was used to see the flow inside the manhole also, and whether it was the minimum velocity of 0.6 meter per second, whether it was maintained or not. Now, as you see, that construction of manhole, because of that, the road got damaged, and the physical inspection revealed that the manhole construction was not properly done, and the safeguards which should have been taken, it was not taken. The shoring or the guarding or the so the road does not get damaged or so. So that actually we saw, and you can see it's clearly visible that manhole was being constructed by the side of the road, alongside the road, but the no shoring or no protection safeguard measures were taken, and because of which actually some sort of road parts so that actually got damaged. Now, investigation of sewage treatment plant, partly operation and partly under construction. So that is the ring bond. Ring bond actually is given for any site, in fact. So maybe airport, maybe a sewage treatment plant or water treatment plant or such other this civil engineering structure, the wide, requiring wide area. What we do actually, we measure that. We take the statistics of floods. So the high flood level or highest flood level we see, and the treatment plant in particular, or that particular civil engineering facility is going to come, that should be or must be safeguarded against the likely flooding. So the flooding, the reference we take the highest flood level, that is actually, say year 1978 is normally taken, for the construction, ongoing constructions also. So we collected that one from the irrigation, micro irrigation department, public health engineering department also. We collected these figures, and we checked whether level was, the ring bond level was above high flood level, so that the treatment plant, once it is constructed, doesn't get flooded also, inundated. This is the operational, the partly operational, this one, the sewage flow into the constructed inlet box. This is the inlet box. So whether inlet box was operating correctly or not, that physically we saw. This is the screened this angle, and then the screen size, that perforations also, that we also checked. This one, all these pertinent components we checked physically. And the flow, the partial flume, I think all of you know, the civil engineers are familiar with the partial flume, which actually measures flow, and it is a flow control device, hydraulic control device. So all of you, who happen to be civil engineers, they must have read the hydraulics or the water resources. So their partial flume definitely was, included in your teaching. So this is the practical, the field partial flume, and we actually checked. As you see that there is a graduated kind of on the wall of the partial flume, from which we got collected the data, and the flow, actual flow, which happened to sort of flow down the treatment plant, so that we checked. Now this is the grit removal unit that is the next to the screen. So that also physically we saw that whether it was operating well or not, and the hydraulic features of that. Then this is another partial flume connected to that, lagoon, that is aerated lagoon also. So that whether it was correctly done, the leveling and all these things, actually leveling, then water elevations, and then we broke some sort of wall, side wall. We checked the reinforcement, whether the recorded or documented reinforcements and tender, as per tender documents, whether it was followed or not, properly or not. This is another, this one. So sometimes, most of the times, our non-intrusive sampling, which you have seen in the my first PPT, the very advanced technique. So that was not available at that time. And in our country, actually, this area should be developed. The civil engineering laboratories, should have these facilities, not uh, not very very costly. It's not that one cannot purchase also, but priority should be given for developing a sort of forensic civil engineering laboratory also. So there actually the videos what you have seen, so the ferroscan and all. So these are actually the non-intrusive, without damaging the structure. You can sort of determine that one more or less to a sort of actual extent or so, more or less. So that could be done, but we had to adopt, or we had to rely on the physical damage, part damage of the structures, and then we sort of repaired that, got it repaired through contractors or so. So we took the samples and then did the testing in the laboratory or in situ or so, measuring tape, the bar reinforcement bar spacing, then the dia, then whether the coating was given or not, and the corrosion, extent of corrosion, so that we checked physically. This is a particular sort of reactor in the field of the sewage treatment or wastewater treatment plant. That is that upflow anaerobic sludge blanket reactor, USB reactor. So that is shown here. That time that was under construction. It was not completed. It was not operational by that time when we visited that. But what we did actually, the leveling, which is very very important in the field of wastewater engineering for STP and also in water treatment plant structures. The hydraulic sort of elevations are important, and also the structural elevations. If the structural elevations are not correctly done according to or adhering to the hydraulic flow diagram or so, then that would be wrong while it would be functioning, and the flow will not take place towards the this forward direction. The backflow may occur. It may be stagnant or so. So lots of problems arise. Because of that, the non-leveling of structures, then wrong leveling also. So we measured in randomly in different, levels, structural elevations strategically. This is the distant views of the basin. That is the basin, entire basin for sewage treatment plant. This is the laboratory testing what we did for the construction materials, and different, that field laboratory cannot provide all the facilities also. So whichever is required, the basic facilities like sieving, as you see here, so that was installed, or that was available in the laboratory, the basic fundamental this field laboratories also, and the rest of the testings were done in the laboratory of recognized organizations and reputed institutions also. And the test reports about that, here there are some sort of the collected or measured values also. For example, for clay bound bricks, that is IS 1077 compliance. The later version also has come here 1986. That time it was the latest one. Minimum compressive strength, so that is actually followed, that 11.86 Newton per millimeter square, passing class designation 10, which was as per tender document. class designation of the bond clay bond brick, that is the 10, was stipulated, and it was complied. Maximum water absorption of 15.45% qualifying for class designation. Then for coarse aggregates also, fine aggregates, we measure that. The crushing value, this is in the range of 10.3 to 11.3%, well within the permissible value of 45% as laid down in the code. This is that, can you see that the code number? Anyone? Hello? Hello?
Yes, sir, we can see it.
Okay. So as per that code, actually, this actually was tested, and it was, checked whether these values were, within the limit or admissible limit also. So all these are written here: water absorption, then the sieving, this one, the size gradation, then this, size distribution or the size gradation, then the impact values. So all these were tested as per the IS code, given IS codes. Fine aggregates, for which the IS 383 and reaffirmed in 1997. So that was there. So that also were checked based on that, according to this, conforming to this IS code. And here there is a list of codes which actually were directly used. But apart from this list, actually, there were other codes also. For different testing or it was restricted to that, but were other codes too. So with this, I thank you so much for your patient hearing and cooperation. I am sorry for the disturbances, which intermediate disturbances with regard to the video display. So here I conclude. If you have got any questions, you can sort of interact now or later, through mails or so. So I again thank to all of you, and particularly the coordinator ma'am, because she has taken pain to be present for all the presentations and delivering her comments and her observations, reporting and all. So for that, a special thanks go to Dr. Madhulisha ma'am. Thank you so much, all of you. Any questions?
Any questions from the participants?
I see some chats.
If
You
you
see
have
that?
questions, then you can save it.
I see some chatting. Not audible, intermediate, that is at 12:03. So then, yeah, sound was not available. Someone wrote. Then subtitles not visible. I'm just reporting the comments through chats.
Okay, sir.
Yeah.
Okay, participants, is
Then
there any
thank you,
questions?
sir.
Then you can ask
Okay.
to sir, and he can clarify your doubts. You are requested to ask. You can unmute yourself and you can ask the questions if you have.
If
I think
yes.
everything is clear to them, and it was nicely presented, sir. So hope they have cleared everything. So, sir, I think so because of that.
It may be, Dr. Madhulisha, it may be other way around also. Maybe that it was not very clear, so that is where people, participants may hesitate to ask any questions also. That also maybe. I'm sharing a light moments, you know.
No, sir, it's not like that. Maybe in some session, like participants are not asking question because maybe they are clear. If they have, they will some doubt. Definitely, they will take that chance and they will ask you. And you have.
I hope so. I hope so.
Okay, sir, your
But
present.
many videos. Let me tell one thing here, that the videos in first this PPT, what I presented, these videos are, you see, that you can get on your own. If you just, video, you can download, or you can see live videos also available on YouTube also.
Yes, yes,
It
sir.
is not that, by a very special means I collected also. It is not all like that.
Yes,
So whenever some testing or forensic related to forensics examinations, if you want to see and view and understand, then you can go to YouTube and you can get lots of these videos also. So which I have chosen some videos according to my choice and limited time which I could collect. It is not that by special sort of means or paths I have collected also. These are available. This one, of course, the second PPT that actually talked about our involvement, as I explained earlier. That was actually, not available anywhere elsewhere. So, but the first one is available.
okay, sir.
A
Okay.
link also means I have given on some slides. The link also, relevant links I have shared.
Yes, sir. Okay, sir. I
You
think
are.
there is no questions, and whatever the questions are there, I think there itself in presentation. I think
Yeah.
one question already, somebody written in chat box, sir. Is there
Hmm.
any scope of geotechnical engineering in wastewater treatment?
Yeah, of course. Geotechnical engineering, because this is the foundation. You know, if the foundation is not, is not strong enough, then the sewage treatment plant will collapse. So, for example, I'm saying that suppose you were laying sewer line, and if suppose the sewer bedding, you know that the first excavation is done, then bedding, concrete bedding, or granular sand bedding also. So these are given, and then over that the sewer pipes are laid. Now, if that kind of foundation is wrong or defective also, entire sewer line, whether the best design, best execution means the laying followed. But if that be the defective one, then in that case, entire things will collapse and will not work. So that is the extent of importance of foundation engineering in STP or sewerage system also. Because the civil engineering stands on foundation engineering. So of course that is there. Anything more?
One question is written, sir, why we don't discuss failures in public domain?
Yeah, public domain. Actually, as I explained earlier, that this is the second PPT that actually pertains to that High Court. This one. So it was basically a sub judice one under this court verdict, and that is why this we had to submit the reports along with the photographs to the honorable court. I'm not naming any court. This is High Court. So and there the litigations are still going on, and some litigations were settled or so. So under such circumstances, definitely I would not, advise or recommend that none of you, quote this one. You can just, see that, but please do not quote. Then you may be in trouble later.
Okay, sir, one more question is there.
Hmm.
Can you please elaborate on the requirement of R&D centers in all technical department in government?
Okay, in government,
Yes, sir.
not
In chat
institutions.
box, sir.
Means you mean to say that government institutions or government organizations?
Technical departments in government.
Yeah, that is, there already. That is, suppose, for example, CBRI in Roorkee, say. So that is actually Central Building Research Institute. All of you are aware of that. Similarly, Structural Research Institute, that is there. So a lot of, environmental research institutes, these are considered to be the technical institutions or organizations dealing with the R&D works related to, different sub-disciplines of civil engineering area. And of course, the institutions, any institutions can build up the forensic laboratory, because that has got high demand, I'm telling you. Because very, very few handful of the institutes in our country do facilities. So if these facilities are there, then in the construction industries also, the incorrect this construction, then unscrupulous things that could be minimized. Forensics examination actually is having very, very important, not only with regard to repair or rehabilitation also, but to streamline the process of developing the infrastructure facilities. And there will be always, the fear of violation or so, if forensics in civil engineering, that is strengthened also. So this is very, very important, and need of the day, you can say.
So now I think the queries of all the participants have been addressed. So,
Yes.
sir, it is an honor for me that you have joined with us in this FDP program as an expert speaker. And thank you so much, sir, for accepting the invitation. Thank you so much.
Yeah, you are welcome. You are welcome.
So with this, we come to the conclusion of this session 11. So I thank you all for your valuable presence and for your patience of listening. And now I request you all to kindly switch on your camera for one group photo.
Shall I be there?
Sir, you can stop your sharing.
Okay, just one. Yes.
So requesting everyone, please switch on your video so then we can take on. Sir, your photo is not coming. It is dark.
Okay, I have possibly. No, it is video is there already.
It is very dark, I think. Yeah, now it is okay. Sir,
Okay.
but your face is not, we can't see you actually.
Now?
You can see in front of camera, then I think we can see. Your can and wall is, I think we can see.
Just one moment. Actually, I'm not very much savvy in that, when setting that video also.
Yes, sir.
I see that the video that is there, but video setting, I should do that. The camera, audio, video, original ratio.
No, sir, you don't have to change the setting. When your video was on, no, roof was visible. You're supposed to, not your face.
So, which I'm now, seeing on the screen. That
you
is
can switch
actually
on your light actually. I think, I don't know why it is very dark.
Yeah, that
We are
is
not able to see you. And
earlier it was there, but now I don't.
it is visible, but you can sit in front of camera so that we can see your face.
No, we are able to see the roof and fan, sir, not your face.
Okay. Just give me.
You might have to look down then at the camera. The camera is at down.
But my camera actually, I see that it is off. Why?
No, maybe you have switched on the camera of mobile. Is it?
Yeah, means I don't know that. Now?
No, sir.
Now it is on, but.
Okay, so anyway, all of you are requested to switch on your video, please, once, so that we can take one photo. Yeah, nice to see you all. Okay, thank you so much. So participants, we will meet again at 3 p.m. for our next session, session 11. Okay, so that will be delivered by Dr. T.V. Bharat from IIT Guwahati in geotechnical field. Okay, so all the participants are requested to kindly assembly on this virtual platform for the next session by using the same link prior to 10 minutes prior to your session time. So thank you all for your presence. Okay, so now you can leave. Okay, sir. Thank you so much, sir.
Okay.
So, shall we
You are,
stop the meeting, sir, now?
yeah. I'm leaving. So
Okay,
I'm
sir.
leaving.
Okay, sir. Okay, sir. Thank you
I'm
so much.
sorry that I could not send the video. Okay, no problem.
Okay, sir. No problem, sir. It's fine
Mhm.
totally, sir.
Earlier it used to be, but now I also don't see on the screen
Yes,
my
sir. Yes, sir. Yes,
picture.
sir. In
Something
online,
happens.
it happens sometimes. Due to some
Yeah.
problem, sir.
Something
Yes,
happens wrong.
yes, sir. Totally.
Showing it is on, but
Yes, sir.
yeah, no.